this problem that asks you to find the value of x that would work for this right triangle. So this is a problem from grade 10 quadratics. So if you're not in grade 10 yet, you will probably find this solution extremely confusing because we're going to be looking at quadratics, including factoring and expanding and things that you haven't seen yet until you reach grade 10. But if you are in grade 10, this is one of those challenge questions that might come up in a test that actually uses a little bit of everything you've learned throughout this term. Let's get into the solution. Let's start by just redrawing that triangle just so I have everything on one page and it looks great. So we had, this one was x, this is x plus 7, and this is 2x plus 3. And of course, this was a right angle triangle, so we signify that with that little triangle, with that little square on that right angle. So whenever we have a right angle triangle, we know that we can use the Pythagorean theorem. A squared plus b squared equals c squared. So if I take the two legs and square the lengths and I add them, that will have to equal the same as the hypotenuse squared. So that means that if I take this leg, x squared, plus this leg, and I'm going to write in bracket x plus 7 squared, that has to equal to the hypotenuse 2x plus 3 squared. And now it's just as simple as pie. We just need to find the value of x that makes this equation true. Easy, right? Well, in order to do that, we actually need to simplify this entire equation, right? We have way too many x's here. We're going to simplify it, and then it's actually not going to be too hard going from there. So how do we simplify it? In order to simplify it, I actually need to expand all of these binomials that are squared. And this, I'm just going to do this on the side. This is what it looks like. So I'm just going to expand them on the side just to keep my work a little bit neat, a little bit more neat rather. So I have x plus 7. When I square that, some of you already know the shortcut to this, but I can rewrite that as x plus 7 times x plus 7. And again, this should be pretty fast for some of you, but I have x times x, that's x squared, x times 7 plus 7x, 7 times x, that's another, plus 7x, and 7 times 7, that is 49. And when I simplify that, I combine these like terms, x squared plus 14x plus 49. Some of you already know that I just square the first value, square the last value, and then double this times this in the middle. But this is what it looks like expanded, okay? So this one, once I expand it, it's going to look like this. Let's do 2x plus 3 squared as well. So 2x plus 3, when I square it, again, you could do the shortcut, but I am going to write it as 2x plus 3 times 2x plus 3. And that gives me 2x times 2x is 4x squared. We're just doing a big review here. 2x times 3 is plus 6x. 3 times 2x is plus 6x. And 3 times 3 is 9. And when I combine my like terms, I will have 4x squared plus 12x plus 9. Again, some of you guys could do this very quickly, but I just wanted to do a review of how to expand. So now that I have these expanded, I'm going to go back into this big, beautiful equation and rewrite it. So x squared just stays as x squared. I'm just going to kind of do this on the side, x squared. And now once I add this and expand it, and I don't need to keep it in brackets because it's just a plus and there's nothing in front here. So plus x squared plus 14x plus 49. And on the other side, I'm going to write the equal sign, equals, and I already expanded on the side, 4x squared plus 12x plus 9. Okay, so now can I find the value of x that makes this equation true? Not quite yet. I need to bring everything over to one side, which is going to give me one trinomial that I can later solve for x. So let's bring everything over to the right side. It doesn't really matter if you do left side or right side, but I want all of the terms on the right side, and on the left side, I'm just going to have a 0. Okay, so if that is the case, I have 4x here, and I'm going to subtract x squared and another x squared. 4x squared minus 2x squared gives me 2x squared, right? So this kind of crosses out. Now I have a 12x here and a 14x here. If I bring this to this side, 12x minus 14x, that's going to give me minus 2x. So I'm just going to kind of cross this out. And I have a positive 9 here and a positive 49 here. I need to bring this to this side. So if I subtract it, it's going to give me minus 40. And these kind of cross out as well. Okay, so now I have a trinomial, and if I factor it, I will have an answer. I will have a value of x. However, and so you might be thinking, okay, so do I use the quadratic formula here, or do I do the complex trinomial factoring? Well, actually, if you pay attention to any of my previous lessons, you always check for a greatest common factor. It's going to make your life so much easier. And here the greatest common factor is 2. And if I factor out that 2, I will actually have a simple trinomial, which is going to be really easy to factor. And I can actually divide everything by 2. including on this side, divide by 2, divide by 2, divide by 2, divide by 2, instead of kind of factoring out in front, because if any 0 divided by anything, any kind of factor is still going to be 0. Makes my life super easy. So 0 equals x squared minus 2x divided by 2 is just x, minus 20. Okay, so now we have a simple trinomial, and you can factor it in just a quick couple of steps. Okay, let's factor this trinomial. Again, I like to do this on the side. Of course, you don't have to, but I'm putting in a little bit of extra work here. So my trinomial is x squared minus x minus 20. What I need to do is find two numbers that multiply to negative 20 and add to negative 1. So let's list all of the, maybe you can just do this in your head, but I like to list all of the factors of 20, start with 20. So 1 and 20, 2 and 10, and 4 and 5, and then if I keep going, I'm just going to be repeating those factors. So now I know that one of the factors needs to be negative and one needs to be positive, because positive times a negative is a negative. And is it going to be the smaller number or the bigger number? Well, they need to add to a negative number, right? If they add to a negative number, that means the bigger of the two factors has to be negative and the smaller one has to be positive. Okay, so now let's see which of the two adds to negative 1, which of the pairs of factors adds to negative 1. 1 and negative 20 is negative 19. That's not it. 2 and negative 10 adds to negative 8. That's not it. And 4 and negative 5, ooh, that adds to negative 1. That means my factors are 4 and negative 5. So I can factor this to x plus 4, x minus 5. Okay, so let's go back to our solution here. So I'm going to factor this to x plus 4 and x minus 5. That is equal to 0. So in order for this to be true, either x has to equal to negative 4, right? Because that factor would be 0, or x has to equal to positive 5. Both of these values would make this equation true, right? So the math is mathing for both of these x values. However, we have to go back to our original problem. Could x equal to negative 4 when we're talking about lengths? A length cannot be negative. So we call this solution x equals negative 4, it's called inadmissible. So the only solution that works in a practical sense is x equals 5, right? Because I could plug in x equals 5 here and have positive lengths. So the math works for x equals negative 4, but it doesn't work in the practical sense. I'm just going to bring this back to over here and say x equals 5 is the solution. Is the solution for this right angle triangle to be true. So here is the full thing again. These are all of the steps. Really, it's very fast. I've added a few extra steps in there. You can take a screenshot and study it if you want. So, but just remember, when you have a fraction in front, it's not any harder than when you have any other kind of number. And let me know if you have any questions. Leave them in the comments, and I will see you next time.